Did you ever play with a slinky as a kid? If you did, you probably made it walk down the stairs. But did you also pinch several of the loops together and let them go? If you did, you would have seen that compressed area of the slinky moves like magic from one end to the other. Looking closely, you would have seen the compressed loops move forward, trailed by an area of the slinky loops that were stretched out. You created a longitudinal wave. To better understand what this means, let's go back to what a wave is. A wave is a disturbance that moves through a medium. When you think of a wave, you probably immediately think of the beach and water waves. Using that as an example, the medium is the water, and the disturbance is the up and down movement of the water. A longitudinal wave is a wave in which the disturbance moves in the same direction as the propagation of the wave. Going back to the slinky example, the medium is the slinky, and the disturbance is the back and forth movement of the slinky. Notice how this description differs from the description of the water wave, up and down versus back and forth movement. The disturbance in the slinky occurs when you pinch the loops of the toy together. When you let it go, that disturbance moves parallel, or in the same direction as the wave that you observe moving along the length of the slinky. The water wave is the opposite, in that the disturbance moves up and down while the wave moves toward the beach. Another example of a longitudinal wave that you experience every day but can't see is a sound wave. Let's use the example of someone talking to you. When your friend says hello, her vocal cords vibrate. This provides the disturbance needed to create a longitudinal wave. The medium is the air, and the vibrations cause a disturbance in the particles that make up air. The longitudinal wave travels through the air to your ear. The small organs inside your ear pick up the vibrations and transmit them to your brain, where you interpret the sounds. A longitudinal wave can occur in any medium. Something creates a disturbance in the particles of the medium, and a wave moves outward from that source. There are different parts to this type of wave that can be applied to any example. A compression is where the particles of the medium are closest together, like when you pinch the slinky loops together. A rarefaction is where the particles are stretched apart. The point halfway between the middle of a compression and the middle of a rarefaction is when the particles of the medium are at rest. In other words, neither compressed nor stretched out. A wavelength on a longitudinal wave is one complete wave or cycle. It is the distance between any two equivalent points on the wave. For instance, it is the distance from the middle of one compression to the middle of the next compression, or from the leading edge of one rarefaction to the leading edge of the next rarefaction. The amplitude of a longitudinal wave is the distance from the relaxed point between a compression and a rarefaction to the middle of one of those two areas. Amplitude is related to energy. The greater the energy of the disturbance, the greater the amplitude will be. For example, the amplitude of a sound wave you generate will be smaller when you whisper and louder when you shout. Longitudinal waves also have frequency and velocity. The velocity of a wave is simply how fast it moves through a medium. Sound waves move fastest in solids, followed next by liquids, and being slowest in gases like air. Frequency is the number of cycles of the wave generated in a given time period. It is usually measured as cycles per second, or hertz. If a wave has a frequency of 1 hertz, it generates one complete wavelength every second. A wave is a disturbance moving through a medium, like the up and down motion of waves at the beach, moving through the water. A longitudinal wave occurs when the disturbance moves in the same direction as the wave itself. Sound is an example of a longitudinal wave. A compression is where the particles of the medium are closest together, and a rarefaction is where the particles are furthest apart. Amplitude is the distance from the relaxed point in the medium to the middle of a rarefaction or compression. A wavelength is the distance between two equivalent points. Velocity is the rate of movement of a wave, and frequency is the number of wavelengths produced per second.